Okay, we did, can you close that door, please, Braden? Okay, so we already did solving one-step inequalities that had addition and subtraction, right? Right? Okay, now what we're going to do, okay, now multiplication and division, this is solving one-step inequalities. Okay, but these are multiplication and division. Okay. Now, these are almost, okay, first of all, how many of you guys found that solving inequalities with addition and subtraction was pretty easy, right?
No.
Okay. So the only difference is this is still pretty easy, okay? But there's a rule that you have to keep in mind. Okay? All right. Okay, so we're going to treat them, first of all, we treat them just like one-step equations, okay? Okay, they are, treat these like one-step equations.
I took my stuff.
Mr. Christie, is it the 27th or the 26th?
27.
Okay,
Okay, so,
26 up on the board.
okay, I'll change it. Okay, so we're going to, like I said, treat these like one-step equations. So if I had something like this, let's say I had negative 3x equals 12, okay? This is a one-step equation. How do I solve a one-step equation? And in this case, this is multiplication. How do I solve this? Brooklyn?
You use division.
I use division. I'm going to divide each side by negative 3, okay, and x would equal negative 4, okay? Easy enough, right?
No.
However, okay, there is a rule. Okay, and this is a very important rule with inequalities. Okay, write this down. Whenever you divide by, not necessarily into, whenever you divide by a negative, you must flip the inequality sign. Okay. All right. You understand what I just said? So let's say I have an inequality with these exact same numbers. I have negative 3x is greater than 12. Okay. I'm going to treat this just like in a one-step equation in that I'm going to divide by what? Whatever is being multiplied by the variable, right? So if I divide everything by negative 3, keep this rule in mind. Anytime, somebody read this to me. What does that say? Lily, read that to me.
Whenever you divide by.
And why did I underline by and make it capital? Because that's important, right? Divide by. Not into. Not necessarily into, but by. Okay, continue.
The negative must flip the inequality.
Must flip the inequality. So am I dividing by a negative here, guys?
Yeah.
I am. Okay, so this is x, but this inequality sign is going to flip. So it is now going to be like this. And what is 12 divided by negative 3? Negative what?
4.
Negative 4. Okay, do you understand that?
Yes.
Yeah? Okay.
Is there more to that? Yes.
There will be. Okay. Do you understand?
Yes.
Okay. Let's look at a couple of examples here. Okay, let's say now, is the same rule if I multiply, if I divide into a negative. Let's see. If I had this, 12x is greater than negative 120. Okay? Well, first of all, if I treat this like a regular one-step equation, what's happening to x? It's being what? Divided or multiplied?
Divide.
It's being multiplied. So the way to undo that is to divide. So I'm going to divide everything by 12. Okay, now this time, I'm not dividing by a negative. I'm dividing into a negative. And what do my rules say? Dividing by a negative means I have to flip it. So do I have to flip this inequality sign?
Yes.
No. This stays exactly the same. I'm dividing into, I'm not dividing by. Okay? So what would this be? Negative 10. Okay?
So we still say we still have a positive, we just change it. Oh wait, never mind.
We didn't flip it. Okay? Now, if I had this exact same problem with the exact same numbers except this 12 was negative, Okay, in this case, would I be dividing by a negative here?
Yes.
Yes, I would. So this inequality sign would have to flip to the other direction. Okay.
So, Mr. Chrissy,
Yes.
so basically you're trying to say is the thing you're dividing by has to be negative in order to flip it? But if it's not
Yes.
negative, you don't have to.
Yes. Correct. But if you're dividing into a negative number, it doesn't matter. Okay, does that make sense?
Yeah.
Okay. And let's see if this is true. Chase, give me a number that's less than 10.
5.
5. If I multiplied negative 12 times 5, what is negative 12 times 5?
Oh, I got it.
What's negative 12 times 5?
60.
Negative 60. Is negative 60 greater than negative 120? Yes, it is. Okay. You understand why we have to flip it now?
No, it's not. Oh, yes, it is.
Negative 60?
Oh, yeah.
Is it greater than negative 20? Would you rather owe me $60 or $120?
120.
That's negative 120.
I owe you 120.
That does
Would
make
you
sense.
rather
Huh?
So that does make sense.
It does. Okay. All right. Now, looking at another kind of problem, let's say I've got let's say I have something like this. Let's say I got x over 5 is greater than 11. Okay? Now, if I'm treating this just like a normal one-step equation, what's happening to my variable here? It's being what? It's being what? It's being divided. How do I undo division? Multiplication, right? Okay? So I'm going to write this twice because there's two ways that you can do this. And I'll tell you the way I prefer is to put parentheses around this whole thing. And whatever I'm dividing by, which in this case is a what? 5, I put on the outside. Those cancel. And now I have, what's 11 times 5? 55. The other way you can do this, I know that x is here. The problem with this, with inequalities, is you have to flip the inequality sign. Okay, and it's a little bit too much to remember. Okay, so 11 times 5 would be 55. But because I went on opposite sides of where these are at, okay, what has to happen? This inequality has to go the other way. Okay, to me, that's too much to think about. I would rather just do this.
But we can do.
You can if you remember to flip the inequality sign.
I'll do that for you.
Okay? Sure. Does this all make sense? Okay.